Hello friends, welcome to my video on neural networks. I know there have been 1 or 2 or 8 neural network videos for Breakthrough, but I bring something new to the table. What that is, I know not. Let's say we want this neural network powered robot to move when it sees a square and stop when it sees a triangle. This neural network would have an input layer where we input the values and features of squares and triangles so it learns how to identify them. Then there are hidden layers where these values are transformed in order to create a prediction between 1 and 0 that the image the robot is seeing is either a triangle or a square. Now as you sit at home wishing you were watching a better video, you're probably wondering what these aforementioned transformations are. So when my neural network is born, it's a stupid dumb idiot, so it takes after its father, but unlike me, it gets smarter. Each node and connection is influenced by weights and biases, which adjust input values to reach the output value. Each node after the input is the weighted sum of previous nodes added to the bias, which is how the transformations are applied. So after adjusting our weights and biases, let's see how it does. Square, triangle. Wow, my son's a disappointment. At least the family tradition won't die with me. So it turns out neural networks have to run epochs or tests on input data to adjust weights and biases. So while my idiot son learns his shapes, let's discuss how this works. Neural networks utilize an activation function, which is a standard function that plots data between -1 and 1. If an input's value is less than 0, it's neglected. If it's closer to 1, it's more close to being true. One such activation function is the rectified linear unit, which is useful because it makes all data below 0 negligible, and it plots all data after 0 on a linear line, which represents the data more accurately. So if the neural network, worked, it would plot the input data on the activation function, and based on where it is, it would move or stay in place. To the 4 people still watching, you're probably thinking, A, where did I go wrong in life to end up this far into the video? And B, okay, it takes data, plots it, transforms it. But how does it even get better or learn? Well, I'm so glad you asked, because that brings us to the please contain your excitement last part of the video, loss functions. Neural networks adjust weights and biases through loss functions. Loss functions plot the margin of error of a neural network based on tests onto a multidimensional graph, and it employs gradient descent to try and lower this. So basically, if our margin of error was a hill, our robot would start at the top of the hill, and it would keep adjusting weights and biases to see how it can get lower and lower down the hill. So to the person singular still watching, you now have, hopefully, an abbreviated understanding of neural networks. But you're probably wondering why they're important. Neural networks are important due to their predictive analytical capabilities and their ability to take input data and draw conclusions from that. So whether you're a doctor trying to make accurate medical prognoses, a businessman trying to make predictions for the next quarter, or a programmer trying to impress his friends, neural networks can make your life easier.